Hey everyone, I wanted to give you an example of conditional probabilities using a contingency table. I went out and found some data about book bans. Specifically, this data is about the number of challenges brought to the American Library Association that they could find by type and by year. So a challenge is not a ban, it's just a question or a recommendation by somebody to say, we think this book should be banned. It doesn't mean that the ban actually happened. Another catch here is that the American Library Association doesn't think that all challenges are reported out to this body where the data was collected. So this might just represent a fraction of the actual challenges out there to books. So what we have here is I collected data on 3 different years, 2016, 2019, and 2022. And I kind of backtracked. I found out the percent of challenges and where they're brought from. So parents are bringing up challenges to books. Patrons at libraries are bringing up challenges. The boards or administrations at schools, for example, librarians and teachers, political and religious groups. And then I kind of lumped all of these together into this other category. So we've categorized the book challenges by type of year, which is one variable, and then who brought the challenge, which is a second variable. So we make columns in our contingency table, and then we have rows. So one of the most challenging types of probabilities to compute are conditional probabilities, because we wonder, how do we actually compute this? If you want to compute any probability, like what percent of challenges are brought in 2016, we would look at the 2016 row, find the total, and then divide it by the grand total to find the percent of these challenges that are in 2016 or any of those other years. So that's a marginal probability, which is different than a conditional probability. A conditional probability says, let's only look at a fraction of the data and then compute a probability. So I have 2 questions here so that we can practice computing conditional probabilities. Find the probability a challenge is brought by a parent given it's the year 2019. So the part we want to focus on is after the word given, because given takes us from the 1,980 challenges and it reduces it to only the challenges that are in 2019. So in the year 2019, if I highlight that, everything that I've highlighted, that's our new world. That's our new, like a subpopulation. So instead of 1980, our population is now 388. And so now we ask the question, so given that we're only in this row, what's the probability that a challenge is brought by a parent? So we look in this one row and find where it matches the column under parent. So we have 68. And then what was our numerator? What was our denominator? The denominator was the total of our row, 388. So we have 68 divided by 388. Now I'm going to have Google Sheets compute the probability here. So I typed in equals and then typed in the numbers, and look, it's already kind of estimated the answer. So after I push enter, here's our decimal answer, the probability. If we want to turn that into a percentage, just move the decimal place over 2 spaces. So that's about 17.5%. But if we want to say the probability, like my question says, we have a 0.175 probability that a challenge was brought by a parent, given that the year was 2019. So now I want to contrast that. What's the probability a challenge is brought by a parent, given it's the year 2020? So our world is no longer the 1,980 challenges. Our world is now only 2022, which is quite a number of challenges. Almost 1,300 challenges were brought against books in 2022. And so now we say, of those, how many of those were brought by parents. So we have to look into the column that has the parents, 381. So I'll type in equals 381 divided by our row total. Go back to the row total, 1269. Push enter. So now our probability is about 0.3. If we want to interpret these as percentages, we can say in the year 2019, 17% or 18%, if I round, 18% of challenges were bought by parents. And then if I go to the contrasting sentence, given that it's the year 2022, we have 30% of the challenges are brought by parents. So we can see that, wow, that's kind of a big difference. And we may wonder, why is that happening? That's something else that we can explore on another question. Look at confounding variables or other influences to our data. So when do you do conditioning with the columns? Just notice I use the row totals. If we want to use the column totals in our conditional probabilities, we might ask, given that a challenge is brought by a parent, what's the probability that the year was 2016? So we would take the column total, 584, and that's our new denominator. 136 would be our new numerator. So 136 out of 584. So to test out these questions, whenever you come across a probability question and you're trying to figure out, is this a conditional probability? You want to ask yourself, does it look like we are slimming down the grand total into a fraction of that? So given is that keyword. We look for what's given. So I kind of read to the end of the sentence first. And then once I know what my given is, then I go back and say, oh, what's the probability of, okay, a challenge is brought by a parent. Then I use that as my numerator. There we go. We have computed 2 conditional probabilities from a contingency table.